Welcome, everyone. Today we're diving into an essential topic that affects laundromats, hotels, and industrial plants: the need for makeup air in commercial and industrial gas dryers. It's crucial to understand why these large dryers require a constant supply of fresh air and what that means for our operations. Did you know that if you stand behind a big commercial dryer while it's running, you can actually feel the powerful stream of air exiting through the exhaust duct? That's right. Every minute, these machines are essentially hungry fans, pulling in air from the room, heating it up with a gas burner, tumbling it through wet laundry, and then expelling that moisture-laden air outside. These dryers can move anywhere from 100 to over 1,000 cubic feet of air per minute, depending on their size and capacity. In facilities with multiple dryers, this can add up to tens of thousands of cubic feet of air being exhausted every minute. So, from the perspective of the building, we really have a powerful exhaust fan in action. The physics of airflow dictate balance, meaning if a dryer exhausts that much air, an equal volume must find its way back into the building. If we don't create designated pathways for this makeup air, the building will start to pull air in through every available crack, gap, or opening it can find. This is what we refer to as makeup air. It's simply the fresh air that compensates for what we intentionally exhaust. But for gas-fired appliances like dryers, it's more than just an issue of comfort or avoiding drafts. It's a matter of safety, performance, fuel efficiency, and potentially extending the life of our equipment. Let's clarify the difference between combustion air and makeup air. Combustion air is specifically the oxygen needed by the gas burner to burn fuel cleanly. Without enough combustion air, we may see lazy flames and rising carbon monoxide levels. Ventilation air, on the other hand, refers to the general fresh air that helps reduce indoor pollutants and carries away heat and moisture. Meanwhile, makeup air is the specific air that replaces that which gets exhausted by dryers and other fans. In older buildings, these three types of air often overlap and come for free through leaks in the building structure. However, as construction has become tighter and the demands on commercial laundry systems have increased, we need to adhere to stricter codes and standards regarding outdoor air supply. The National Fuel Gas Code, for example, emphasizes that if exhaust fans and clothes dryers disrupt the operation of any fuel-burning appliances, we must provide additional makeup air to ensure that all appliances can function safely. Mechanical codes add further layers, emphasizing that engineers need to demonstrate planned pathways for makeup air once we reach certain exhaust thresholds. This is especially relevant when any appliance exhausts a significant volume of air. If we consider the International Mechanical Code, for example, it states that installations with dryers exhausting over 200 cubic feet per minute must have makeup air provisions. This is a critical requirement for dryers installed in smaller rooms or closets, where minimum opening sizes for air supply are specified. If you're operating in a residential context, similar thresholds apply. Notably, NFPA 54 states that we must supply makeup air whenever various exhaust systems compete for oxygen. It is vital for us to understand that codes set minimum requirements, and that a design barely meeting these standards might not perform effectively in real life. In fact, many engineers design well beyond the minimums to ensure dryers function efficiently under actual conditions. So, how much air does a commercial dryer consume? For residential dryers, we often see exhaust flows between 100 and 225 cubic feet per minute. However, commercial and industrial dryers are much larger and can easily reach hundreds of CFM, with some high-capacity units moving over 1,000 CFM. This means that in busy laundromats or industrial settings, we might be looking at exhaust volumes exceeding 10,000 CFM during peak operations. If we exhaust that much air without providing a corresponding source of makeup air, we'll encounter significant negative pressure in the building. This can create uncomfortable conditions, hinder the opening of doors, and possibly cause problems like backdrafting in combustion appliances. Manufacturers of dryers are aware of this, which is why their installation manuals typically include make-up air requirements. As engineers, we must combine the manufacturer's recommendations for make-up air with the total capacity of the dryers in the facility and relevant local codes. If the diagnostics show that we're exhausting more air than can be replaced, we need to design a robust make-up air system. Otherwise, we'll observe a variety of issues. Slow drying times and increased customer complaints may arise as dryers struggle to function efficiently without enough air. Overheating can lead to frequent shutdowns, and building pressures may become troublesome, with doors slamming or being hard to open. Lint and odors may move into adjacent spaces, creating cleanliness issues. Therefore, it's vital to anticipate these scenarios when designing systems for commercial laundries to ensure we provide sufficient make-up air. To sum up, a well-implemented make-up air system is integral to the overall performance of gas dryers. It helps maintain a balanced atmosphere, supports safe combustion, and contributes to the comfort of both staff and customers. By ensuring that we account for make-up air from the early design stages and adapting as needed, we can help our dryers operate at peak efficiency and keep our operations running smoothly for years to come.